Let's do refraction of light through a prism. Really is a prism. It is nothing but a triangular solid glass material which has got plane surfaces on all of its sides, and it refracts the light rays. Just because it's glass and the medium is denser, so when light rays pass through it, they refract it. See the light ray pass through a glass slab. What is the speciality when light ray is passing through a prism? Is when the light ray is passing through a prism, it is breaking the light ray into 7 constituent colors. Mind the word constituent. The constituent means it is made up of. That means white light is made up of 7 colors and the prism is only splitting it. Prism is not making, they're not manufacturing these 7 colors. They are just splitting it, and that's the reason prism is important, because it is splitting the white light into its 7 constituent colors. I think it's fine, but then how they are splitting? So the white light is, this is a white light, this is white light, and this is how refraction is happening, because this is a separation between the rarer and denser medium. So they're having a refraction, and while they're coming out, okay, these are the emergent rays, and there are band of 7 colors. This is violet, indigo, blue, green, yellow, orange and red. So we have a band of colors. Remember, there is a band of colors which is on the screen. This band of color is known as spectrum. The process, so band of colors is known as spectrum. The process of white light splitting, process of white light splitting, process of white light splitting into its parts. Okay, this process is known as dispersion. Okay, and the colors which happen on the spectrum is VIBGYOR, VIBGYOR from the below. See this VIBGYOR. This is how the colors are split. So it is said that the prism does not produce color on its own. It's not making, it's not innovating any color. It's just splitting. Just splitting the white light, and the white light, that means, is made up of 7 colors. So white light is made of 7 colors, hence we say that it's constituent colors. Constituent means it is actually made up of those colors. This is a triangle, a prism, and this is known as the angle of the prism. So if I have a prism which is called A, B and C, angle A is known as the angle of the prism. So this is known as the angle of the prism, right? If a ray of light is hitting the prism, anything which starts is known as incident ray. So this is incident ray. Here the refraction is taking place, and this is the normal at the point of separation between the two media. So the incident ray with the normal is known as the angle of incidence. The refracted ray with normal is known as angle of refraction. This is refraction number 1. Here also there is a refraction which is taking place. This is refraction number 2. Why? Because from here the light ray will again go away. Where will it go away? It will go away from normal. So whenever the light ray comes out, it comes towards the base of the prism. So base BC is known as the base of triangle. So it is known as base of the prism. Please remember, the light ray is always bending towards the base of the prism, and this is known as the emergent ray. Emergent ray. Now I'll draw it with another color. This ray was supposed to go like this, right? But due to refraction, it is deviated from its path this much. So how much is it deviated? This much. This much is the deviation due to refraction, and hence this is known as the angle of deviation. Angle of deviation is written by this. So this is known as the angle of deviation. What is the dependence of the angle of deviation on the material of the prism? Please remember, material means refractive index. Why? Because if the material is too dense, I suggest you look at our past videos for refraction. If the material is too dense, then the refractive index is high. That means it has a high refractive index. Okay, this is the meaning of high density. So high density means it will have high refractive index. Why? Because it will bend the light ray more. More bending means more refractive index. So now we'll get to know what is the angle, how much is the angle of deviation depending on the refractive index. Learned earlier that violet is the most deviated. And violet, you should know, has got the least wavelength. Okay, that means least wavelength is most deviated. And so what is the dependence of the angle of deviation? Violet is the most deviated. So who's most deviated? Less wavelength. So this is how the wavelength or the color of light is dependent on the deviation. And who is least deviated? Red. Red has got a large wavelength, as you can see here. Okay, so large wavelength, less deviation. Less wavelength, more deviation. If you draw it like this, it will be very simple for you. It has been experimentally observed that this was the prism, right? And when the ray of light was split and it was emerging like this, and this was the deviation, which we did just a while ago. And this is known as the angle of deviation. Now we'll draw a graph relationship between angle of incidence and angle of deviation. Here we see that as in the first, as the angle of, so this is the angle of deviation in the y-axis, and this is the angle of incidence in the x-axis. As the incident angle increases, the angle of deviation decreases. Okay, then it comes to a certain minimum point, and this is known as the angle of minimum deviation. Okay, minimum deviation. Further on, if I increase the angle, here it was increasing and deviation was decreasing. From the point of minimum deviation, if I go on increasing the angle of incidence, the deviation also increases. This graph, okay, is important because they might just give this graph in the exam and ask you what is it showing and how is the angle of deviation related to the angle of incidence. Now the position, mark this very carefully, hear this very carefully. The position of a prism with respect to which the incident ray suffers minimum deviation. Incident ray suffers minimum deviation. That is, graphically, it is this part of the graph. That is known as the angle of minimum deviation. Okay, and experimentally, it is found that when it is at minimum deviation, the angle of incidence is equal to the angle of emergence. You see that due to refraction, practically it looks bent, but actually the pencil is here. Okay, so this is the real depth, and then this is the apparent depth. This concept of real depth and apparent. We have to see that what is the refractive index. Refractive index in terms of real depth and apparent depth. When there is a real depth and when there is an apparent depth, that means this is a shift. It has shifted up. So that is known as the lateral shift. Anyway, so the refractive index is equal to, the formula is real depth by apparent depth. Real depth by apparent depth. This is the formula of refractive index in relation to real depth and apparent depth. So from there you can find anything, either it's 1 or 2 or 3. And what is the meaning of the word shift? So the shift is equal to real depth minus, so real depth minus apparent depth, right? Real depth minus apparent depth. What is apparent depth out here? So apparent depth cross multiplication. So apparent depth AD is equal to real depth by mu, right? From this we can know. So instead of apparent depth AD, I can put this one out here. So this one is shift is equal to real depth minus this will come here in place of apparent depth, which is bracket starts real depth by refractive index, right? So if I take, hence shift is equal to, I'm just deriving a formula. Real depth and real depth is there 2 times, so we can take real depth as common into 1 minus 1 by refractive index. So this is the formula of the shift. The more the shift depends on the refractive index of the medium. The shift depends upon the color or wavelength of the incident light, and it depends on the thickness of the denser medium. That's all. Phenomenon of refraction, if the fish is actually here, so he will start incident ray and the incident ray will come here, point of separation between 2 media, he will go away from normal, right? Eyes actually see a straight line, so I will see straight line from here till here. That means what is the actual depth, actual fish will apparently look like the fish has got raised up out here. So what are we taking, what is a takeaway from here is that from here to here is the real depth, that is the fish, actual fish. And this is the apparent depth. So this is a concept of real depth and apparent depth. Hey guys, thank you for watching. We propagate in the philosophy called Let's, because it's Sangeeta's Let's Learn Academy. So let's join hands together and make science a beautiful, beautiful experience.